June 18, 2023. A small experimental submersible begins its descent into the North Atlantic Ocean. Inside are 5 people: explorers, a billionaire, a father and son, and the CEO of the company operating the vessel. Their mission: to visit one of the most famous shipwrecks in history, the Titanic. The wreck lies nearly 4,000 meters below the surface. At that depth, the pressure of the ocean is crushing. More than 380 times the pressure we feel at sea level. A place where even steel can fail. A place where mistakes cannot be corrected. At 9:45 a.m., communication with the sub suddenly stops. No distress signal. No emergency call. Just silence. What began as an adventure quickly turns into an international search operation. Ships, aircraft, deep-sea equipment, all racing against time. Because inside the sub, oxygen is limited. Experts estimate the passengers may only have about 96 hours of air. For days before survival becomes impossible. But what investigators later discover changes everything. The sub never reached the Titanic. It never made it close. Something catastrophic happened during the descent. Something so sudden that no one had time to react. The vessel had imploded. In less than a second. Tonight, we examine the design decisions, the warnings, and the risks that may have led to one of the most shocking deep-sea tragedies in modern history. This is the story of Titan. The submersible was operated by a private company offering deep-sea expeditions. Passengers paid large sums of money for a rare opportunity: to see the Titanic with their own eyes. Unlike traditional research submarines, this vessel was designed to be smaller and more accessible. It was called Titan. The sub was built to carry 5 people. 1 pilot. For passengers. Inside, space was extremely limited. Passengers sat close together in a confined cylindrical chamber. There were no seats, no large windows, only a small viewing port at the front. The journey to the Titanic would take nearly 2 hours, slowly descending into complete darkness. At extreme depths, sunlight cannot reach. The environment becomes silent, cold, and unforgiving. Any equipment failure at this depth becomes life-threatening, because rescue operations are extremely difficult, and time is always limited. Despite the risks, interest in deep-sea tourism had grown. For some, the chance to see Titanic in person was a once-in-a-lifetime experience. But experts had concerns, because deep ocean exploration requires precise engineering, extreme safety margins, and careful testing. Any weakness in structure can become fatal under pressure. Years before the disaster, some engineers and industry specialists expressed concerns about the sub's design. Unlike most deep-sea vehicles, Titan used a combination of materials, including carbon fiber. Carbon fiber is strong, but under extreme pressure, its behavior can be unpredictable. Deep ocean pressure is not similar to pressure on land. It compresses from all directions. Even microscopic weaknesses can grow over time. Repeated dives increase stress on materials. Some experts warned that repeated exposure to pressure cycles could weaken the structure. Others questioned whether enough testing had been performed. In traditional deep-sea engineering, certification from independent safety organizations is considered critical. Certification ensures the vessel meets strict structural standards. Reports later suggested the Titan sub was not certified in the same way as many other deep-sea vehicles. Despite concerns, expeditions continued. Passengers continued signing up, and each dive pushed the limits of the vessel. Several days later, search teams discovered debris on the ocean floor. The debris field is located not far from the Titanic wreck. Analysis confirms the worst possibility. The submersible experienced a catastrophic implosion. An implosion occurs when external pressure exceeds the structural strength of a vessel. The collapse happens instantly, in less than a second. At extreme depth, the force of water pressure is overwhelming. The structure compresses inward with incredible speed. Experts explain that the passengers likely had no time to react. The event would have been immediate. Investigators begin examining possible causes: structural fatigue, material failure, design limitations. All possibilities are considered. The tragedy raises serious questions about deep-sea tourism safety and the importance of engineering oversight, because at extreme depths, even small risks become critical. The Titan disaster sparked global debate. Should experimental vessels be used for tourism? Should stricter regulations apply to deep-sea travel? Exploration has always involved risk. But history shows the importance of safety standards. Many engineering disasters reveal similar patterns. Warnings ignored, risks underestimated, decisions made under pressure. The deep ocean remains one of the most dangerous environments on Earth. Beautiful, mysterious, but unforgiving, technology allows humans to explore deeper than ever before. But nature does not allow mistakes. The Titan tragedy reminds us that innovation must be balanced with caution, because progress without safety can lead to disaster. 5 lives were lost during the expedition, 5 individuals seeking discovery, but their journey ended far below the surface, hidden in darkness, at a depth few humans will ever experience. Their story now becomes part of history, a record of ambition, risk, and the consequences of engineering decisions. Because every disaster leaves behind questions, and every question leaves a record.